This video is over Lesson 82, solving multi-step compound inequalities, and it is for my Algebra 1 class. So, ladies and gentlemen, this really is just a lesson where we're putting together a lot of skills we've already gone over. So first of all, when it comes to compound inequalities, remember that they come in basically one of two forms. It's either joined together by an and or joined together by an or. If it's joined together by an and, then this is only going to be the intersection of the two graphs. So in other words, graph just the overlap of the two individual graphs. If it's an or, it's going to be a union of the two graphs. Or in other words, graph both of them together. So just wherever one of them is, graph it, and then put them together on the same line. So the other thing that we need to be watching out for as we solve, remember, is that whenever we add or subtract, our inequality will stay the same. Whenever we multiply or divide by a positive, the inequality will stay the same. It is only when we divide or multiply by a negative that our inequality will change. So with that being said, let's go ahead and dive in. Remember that we solve these just like you would solve an equation. So I'm just going to treat this like two separate equations. So here we go right here. I've got 4x minus 7 is less than 3. So if this was an equation, I would start by adding 7 to both sides. That would give me 4x, and since it's addition, it'll stay less than 10. And then I'm going to divide both sides by 4. And so I'll get x, and since that was a positive, it'll still be less than. And then 10 divided by 4, I'm going to choose to go a decimal this time. So 4 goes into 10, 2.5 times. On the other side here of my or, I would add 19 to both sides. So that 2x then will still be greater than, and a negative 7 plus a 19 gives me a positive 12. Divide both sides by 2, and since that's positive, it'll still be x is greater than, and 12 divided by 2 is 6. So if I go ahead and move on to graph that, I have two boundaries. Remember, these are going to be treated as our boundaries. So we need to make sure that we've got on 2.5 and we've got on 6. So I'm going to start with, sorry, not negative. I'm going to actually start with a positive 1. And then we'll go on to 2. And then I'll have my 3, 4, 5, 6, 7. And I got room for an 8, so I'm going to throw it on there. And just give some space there. Now, ladies and gentlemen, we need to do a little bit of thinking. Okay. So we have a boundary at 2.5, and since this is a less than, it's going to be an open dot boundary. And the less than is telling me to go less than. So that's going to go that way. This guy over here is a boundary at 6, and it's greater than, so greater than is telling me to go this way. And since this is an or, it's just going to be the union of these two, or just graph them both together. So there's no problem that these don't overlap. We're just going to graph both of them on our number line. So down here, I'll have an open dot at 2.5, and then I'll shade in off to the left there. Open dot at 6, shade off to the right here, and that's it. And there we go. That's my graph. Now, a quick word. If this had been an and, remember the and is only where these overlap. So since these do not overlap at all, if this had been an and, we would have written no solution, and it would have just been a number line with nothing highlighted. No boundaries, nothing highlighted, just open. Okay. Moving on, let's take a look at our next example. Now, in our next example, we don't see the words or and, but remember, when we see this compound inequality where it's been continued, that this is really an implied and. And so we're saying this inequality right here and that inequality right there. But since both of them have the same part right there, we were able to put them together. Now, a quick check on these. These two symbols here should be going the same direction. Okay, they don't have to be the same, exact same, but if this is a less than, that needs to be a less than. If this is a greater than, that needs to be a greater than. As far as the equal to's go, that's where they can be different. So this could be a less than, and that could be a less than or equal to. That's the equal to part is not a big deal, but they do need to point the same way. The other thing we need to check real quick here is if we were to take out the middle part, is this true? Is -9 less than 11? It is, so we're good. If any of those things had not worked out, we'd be in a situation where we'd say no solution. So since it all works out, we're going to go ahead and solve this. Now, first things first, we always want to simplify. So noticing I've got a 3x and I got a 2x, we're going to combine like terms. So -9 is less than or equal to 5x minus 4, which is less than or equal to 11. Now here I don't really have two sides, but because I've got these two symbols here, I really have three sides. So we're going to change our vocabulary here a little bit, and we're going to do everything to all sides. So first things first, to solve this I want to add 4 here, which means I need to add 4 here, and I need to add 4 there. -9 plus 4 is a -5, which will be less than or equal to my 5x. Those will cancel. So then less than or equal to 11 plus 4 is 15. And then finally, I would want to divide this by 5, which means I need to divide all sides by 5 as well. -5 divided by 5 is a -1, which is less than or equal to x, which is less than or equal to 3. Now, the nice thing about these statements, when they work out for us, is that the graphing is very simple. There's not a lot that you really need to think through. So I'm going to go start with a -2, -1, 0, 1, 2, 3, 4. I'd like to have at least one number extra on each side, please, when you're doing this on the homework. Just gives it a little breathing room. And now since both of these are or equal to's, it's going to mean closed dots at each of those boundary points. And since the x is in the middle of these two numbers, the solutions will be in the middle of those two numbers as well. All right, and for the sake of space, I'm going to actually go on to the back of my paper now. I've already got an example there for you written down. So our third example today, we're going to look at another OR. So we'll go ahead and dive in and just start solving. So with this guy, I would add my 18 to both sides here. Remember your SAD map. I want to get b by itself, so add 18 to both sides. So this will be a 6, which is greater than or equal to a -6b. Now I want to get rid of that -6, so I'm going to divide it since it's multiplying with my b. Now since we are dividing by a negative, this is the time that our symbol will flip. And so now it'll be a less than or equal to. 6 divided by -6 is a -1. And then over here, we'll just have b. We do typically like to have our variables first here, so I'm going to flip that around. And since the open part of this was facing the b, I want the open part still facing the b. So my solution to the first part is b is greater than or equal to a -1. Come over here to the other part, and I'm going to do some simplifying first. I'm going to distribute that in. So a -2 times 4 is a -8. A -2 times a -b is plus 2b. And that then will be greater than 10. Now remember, the reason why the symbol didn't change here is because what did we do? Did we multiply or divide both sides by a negative? No. We used the distributive property. Combining like terms and distributive properties do not change our inequality symbols. So this is fine right here. Still going to be greater than. Now I'm going to go ahead and solve. So in order to get a 2b by itself, be careful, do not subtract 8 on both sides. Okay. Since this is a negative 8, we're going to add 8 to both sides. So that's a negative, we'll add 8 to both sides. So that'll leave me with 2b, which then is greater than 18. Divide both sides by a positive 2. Positive will keep this a greater than. And so b is greater than 9. All right. And now we're going to put these together and graph them. So remember, with an OR, this is going to be the union of these two. So it's just going to be the first one and the second one put together on the same number line. So let's consider what that's going to look like then. So I've got a negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I need just a little more space. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. There we go. All right. So if I think this through, I have an open or closed dot here at negative 1. And this is greater than or equal to, so this is going to send me off to the right. But then we have an open dot at 9 that will also send me greater than off to the right. Now, since this is an OR, remember that this is going to be the union of these two, putting these two together. So it's not about where they overlap, it's just putting them both together. So the reality is here that this is just going to continue on and on and on and on and on forever. And so it's going to kind of wash over all of this stuff here, which means that even this open dot here actually will become a solution, because it's a solution to this part over here. With an OR, we only need one of these to be true, not both of them. So the fact that it's a solution to this means it's a solution to the compound inequality. So this actually will only have one boundary. It turns out it is the same. This compound inequality is actually just the same as this right here. Now that's going to be unusual to come up on your homework, but it can, and it can come up in the future, which is why I want to expose you to it. Most of the ones on your homework are going to be either like our first example or our second example. Okay. And I want to take you through one last example here now. I might want to take a second and just copy down our chart there and our question. So let's say that you start the semester off, and you started off a little bit on the rocky side. Your first test score of the marking period is a 72%. Your second test score is a 76%. Your third is an 81%. Your fourth test is a 90%. So you're doing better. You had a rough start, but you're coming up. You're making, obviously you're making the right choices. You're doing better and better. The issue here is you've only got one score in the A range. There's no way that you're going to be able to have an average test or an average for the quarter if the fifth test is the last test. There's no way you're going to have an average in the A range. But what's it going to take to get it in the B range? So can we do it? So I want to know, what can that fifth test be in order to still be in the B range for our test average? So we're going to create a compound inequality for this. In order for the average to be in the B range, I'm going to do this double big so it just really stands out here. We need a score that is at least 80%, or an average that's at least 80%. So 80% is going to be less than or equal to my average. That's what I need to be in the B range. Now, part of being in the B range also means that our average will be less than 90%. Now, obviously, we'd be okay with it being more than 90% or even equal to 90%, but that is what the B range would mean. It would mean that our average is less than or equal to, our 80 is less than or equal to the average, and the average is less than 90. That's the B range. So, and we'll see here in a second why we're going to include that. So now let's get the average. So algebraically, for the average, we express averages as a fraction. So 72 plus 76 plus 81 plus 90 plus x. Remember, we add up all of our numbers, and then we divide by how many there are. So from here, I'm going to just shrink this down to a single line now from here, now that we've got that established. So 80 is less than or equal to, and I'm going to simplify here. I'm going to add those four numbers that I can. I'll put my x first. If we add those up, we should come out with 319. So x plus 319 over 5 is my average. So 80 is less than or equal to x plus 319 all over 5, which is less than 90. And now we can go ahead and solve. So we're going to think about our SAD map. Remember that there are invisible parentheses around numerators, which means we cannot take care of this plus 319 until we've first taken care of the 5. So I'm going to multiply each side by 5. So I'm going to have 80 times 5 here. This will still be less than or equal to. I'm going to have 5 times my fraction. And on the other side, I'll have 90 times 5. So let's continue. Simplify that now. I get 400 is less than or equal to, the 5's will cancel, leaving me with x plus 319. And this will be less than 450. And then finally, subtract 319 here, which means we've got to also subtract 319 from everywhere. So over here, I discover that my average, or my fifth test, my x, at the smallest can be an 81%. If I can get at least an 81%, then I will manage to be in the B range. And then 450 minus 319 is 131. That means that as long as my score is under 131%, that sounds rather doable, I will be in the B range as well. So what we see here in this high end, while we'd love to get above 90% for my average, are we going to get 131% on our final test? Highly unlikely, and not in my class. So the reality is there's no way to bring the test average up to the A range at this point. But especially the way the scores have been coming up, as long as we can do as well as we had done the last couple of times, we should be able to at least pull out something in the B range. And that, ladies and gentlemen, is the end of this lesson.